So what we're going to do quickly is recap arithmetic sequences from Igcse. Now, there are two formulas that you need to know. One was given to you and one you had to learn. So what do we know? We know that un equals a plus n minus 1d. Brilliant. And some of us would have remembered Sn even though we didn't need to. N over 2 times a. Is it a? 2a. Well done. Plus n minus 1d. Now, you're probably thinking, oh, more formulas to learn. Great news for you guys. They give you both of these formulas in the formula sheet. Okay? They're here in the formula sheet. If you don't know them, write them down just so that you have them available for you during this lesson. So what we're going to do today is we're going to go through all the GCSE level questions to make sure our foundations are secure. Okay? Okay, so question 5. We have a 2-mark question, and this is quite a standard one for GCSE. Now, you might remember doing this in terms of we've got to write down the nth term. So you might remember going, right, 7n plus, so 7 plus what is 11? 4, okay? And then 11 plus 15? Plus 4. So then you might remember doing 4n, and then we say, how do we go from 4 to 7? We add 3. So you might remember doing 4n plus 3 and doing it this way. However, what we're going to do is we're going to make sure we're only using the formula. Now, in theory, this formula should get us to this, or else what would the point of being the formula be? So let's break down the formula. So the formula is un equals a plus n minus 1 d. Okay? So, let's see what's happening. Let's break it down. We need to know, what does a stand for? The first term. So in our case, a is our first term, which is 7. Perfect. Then, what does d stand for? Difference. Okay, so our difference we know is 4, because each time we add 4. So I'm going to make sure that each time it's really good practice to write down everything we know. We know that our A is 7 and our D is 4. Okay? Next up. It then says write down an expression for n. So un means a specific term, right? So if we want the formula for the nth term, we're going to fill out this now. So we're going to get 7 plus n minus 1 multiplied by 4, because we're going to substitute everything in, right? Let's expand and simplify this. So we're going to get 7 plus 4n minus 4, which is going to give us 4n. 7 minus 4 is in fact plus 3. So you can see that we've proved that method that took us a second, literally this method here took us like 2 seconds to do, right? Yeah. However, that's because we technically did this formula. We just did it in a different way, in a quicker way, okay? We need to understand this formula though, right? So we would never in the GCSE do this question in this way. We will need to use this formula all the time now for the A-level. All right? So now we've got that. Brilliant. Any questions? Perfect. Okay, so now we're on question 1. Okay, these are all in different order. You remember we just sorted the order, right? Yeah. So, this is a 4-mark question on the GCSE. Now, let's read what's going on. So, we have first 3 terms of an arithmetic series, okay? So, let's go back to what we know. So, we have term 1, term 2, term 3, right? 3 consecutive terms of an arithmetic sequence. Prove that the common difference is 12. So, we need to prove that we add 12 every time. Now, it's a bit different when we have to prove something, okay? So what I like to do with this kind of stuff is I like to go back to basics, right? And I like to think in my head, well, what would happen if this was already numbers? So let's just go completely off task for a minute. Let's pick a sequence. So 4, 7, and what would the next one be?
11.
10. So, what is the difference here, guys?
3.
3. Okay. How could I show the difference is 3 using all 3 of these numbers?
You can see that 4 plus 3 is 7.
Yeah, I know we can see that 4 plus 3 is 7. But using these numbers, how... Oh! So we know that 10 minus 7 equals 7 minus 4. Okay, because we know this one minus this one should equal this one minus this one. Now we're talking. This is really smart. So using this number sentences, we're going to apply the theory then. So this is the same as saying 20x minus 52 minus which one? 8x plus 2 equals, this is equivalent to 8x plus 2 minus 2x plus 23.
Why didn't you just solve it like...
And then we just solve it.
So then like 20
Okay, so let's give it a go. Right, so now we've shown our number sentence. This is a fact, right? And we've just what you remember sometimes I always say, like, what do you notice? Let's go back to basics. Like, let's theorize. Is theorize a word?
I think so, yeah.
It is now anyway. If it wasn't, we'll add it in, okay? Like, theorize means experiment in your head and see what would happen if we put numbers into the equation, right? So now let's solve this then. So we have 20x minus 52. Now remember, this is minus times 8x is minus 8x. Minus times 2 is minus 2, okay? Please, you know, we're going back to GCSE here. So we're going to get 8x plus 2. Minus times 2x. Minus 2x. Minus times 23. Minus 46. Okay, now I'm going to simplify both sides, okay? So what's 20x minus 8x? 12x. Okay? Minus
23. Yeah, it's minus 23, but it's not minus 46, the last thing.
minus 20. Oh, what have I done?
You did minus
Multiply it by 2. Sorry, guys. See? Even I've done it wrong. Right? Just be careful. Okay, well done for spotting that mistake. So we're going to get 12x. What's minus 52 minus 2? Minus 54. What's 8x minus 2x? Minus 6x. What's 2 minus 23? Minus 21. So what am I now going to do to both sides? Take away 6x. So I'm going to get 6x minus 54 equals minus 21. Now, why am I showing all my steps, by the way? Why am I showing all my steps? No, because it says prove as well. Okay? Because it says prove in the question, I need to show every stage of my working, okay? I can't ever jump a stage, yeah? So, next up, after I do this, what am I going to do to both sides? Add 54. So then I'm going to get 6x equals, what's 54 minus 21? 33. Okay. How do I definitely know I've gone wrong somewhere?
Because it's not going to be 12.
24.
Because is this going to give me 12? No, and that's what we had to prove, right? Okay, someone help me with my mistake.
I've done the same thing also, and I got.
Has everyone done the same answer?
Yeah. Because I really started. I was just looking, I was like, that doesn't make.
Wait, are you sure we all just haven't made the same mistake here?
Maybe to the...
We must have done the same mistake, surely.
What is the mistake?
Like, because obviously right now, x does not equal 12, and that's what we have to prove, yeah? X would equal 12 if 6x equals 36, yeah? This is what we want. Technically, 6x equals 36. Maybe we've all added wrong. Let's double check, everyone. Did we write, first of all, we always check, did we write everything out correctly? 2x plus 23, yes. 8x plus 2, 8x plus 2, 20x minus 52. Perfect. 20x minus 52 minus 8x minus 2. Brilliant. 8x plus 2 minus 2x minus 23. Everyone happy?
Yes.
What's 20x minus 8x? 12x. Perfect. What is minus 52? What's minus 52? Minus 2.
Minus 54.
Brilliant. Okay, so we know that's right. What's 8x minus 2x?
6x.
Brilliant. Okay. Plus 2 minus 23?
Minus 21.
Okay. Right. 12x minus 6x? 6x. What's minus 21 plus 54? Someone get a calculator. It is, isn't it? Someone give me the mark scheme.
Bring back the mark scheme.
It must be.
I don't have that question.
Pass it here.
I don't have that question.
I gave it to you.
Give me only.
Okay. Guys, everyone here has made the same assumption, and everyone, including me, has fallen into this trap. How ridiculously silly, but also hilarious. Right, are we ready, guys? X is not the difference. We've got to work out the difference is 12. Okay, we've got to substitute. We've got to substitute X in to find it. So, let's carry on. Don't think you've gone wrong and lost your mind like we did. Let's do this. So, what does X equal now? 33 divided by 6, which is 5.5. Now what I'm going to do is substitute X into each term. So, if we had here 2 times 5.5 is 11. 11 plus 23?
That's
34. Okay, next term. 8 times 5.5 is 44.
46.
Plus 2?
46.
46. 20 times 5.5 is
110.
110 minus 52?
58.
58. Guys, is the difference now 12 each time?
58 minus 4.
Okay, hands up. Who feels like a bit of a fool? Yeah, absolutely. So do I. Okay, can we believe we all got tricked? Okay, and is this a GCSE question?
Yes.
Yes. So, what this proves to us is this. Whenever we do these questions and we check that this is right. If we don't have the mark scheme, essentially, really, we should persevere and go back and read the question. Okay? Well done, guys. That was really fun. So, here are the first 5 terms of an arithmetic sequence. So, really, we know the formulas that we may have to use is UN equals A plus n minus 1d, or Sn equals n over 2 lots of 2a plus n minus 1d. Okay, so these are the 2 formulas because it said arithmetic sequence, yeah? And now I have a sequence, and it says find the sum of the first 100 terms in the sequence. So step 1, we're going to write down everything we know. What do we know? We know the first term is?
7.
So A equals 7. We know the difference is? 3. So D equals 3. And N, what does N equals? N is going to equal 100 because we want the first 100 terms.
Oh, yeah.
So now we have everything, we want sum. So the sum of the first 100 terms equals N over 2. Remember, this is the formula and we've got to fill in all the blanks, right? Something over 2 multiplied by 2 lots of something plus n minus 1 lots of d. Remember, this is the formula. This is literally we're filling everything in. So 100 is my n, 2 lots of a, which is 7, plus n, which is 100 minus 1, lots of d, which is 3. So I'm going to get 50 times 14 plus 99 times 3, which is 297. Okay, I can put this into my calculator. What do I get?
Miss,
So when you're finding the first 100 terms, use
Yeah.
the bottom equation, the bottom formula.
When I'm finding the first 100 terms, I'm going to use the equation which says the sum. This one is just going to find me a term. This equation is used for example, if I want to find the 10th term, n is 10. If I want to find the sum of, okay, so this is a sum, and this is just a term. What's 50 times 311?
15550.
15550. So there is the sum, is that right? Yeah, perfect, of the first 100 terms. So here are the 5 terms of a arithmetic sequence. So what formulas am I going to be looking at? The UN, which is a plus n minus 1d, or Sn, which is n over 2, 2a plus n minus 1d. Now, as I said, you don't need to remember these, but have them with you. Either have them in front of you or write them down. Right, now, let's read the question. Here are the first 5 terms of an arithmetic sequence. Here we go. From this, what do we know? What is A? 8. I haven't even finished reading the question yet, and I'm already being able to write stuff down. Now, some people say you should always read a question first and then go back and do it. However, you know, we're going to try something a bit different, and that's okay. What's my difference? 7. Okay, now let's actually read the question, right? Work out the sum of all the terms from the 50th term to 100th term. Okay, so basically, if I had all of these terms, right, let's say I worked it all out, I just want from the 50th to the 100th term added up. That's what I want. So, absolutely. So we're going to work out the sum of the first 100 terms, because this is then going to be all of this, right?
Yes.
And then we're going to take away the sum of the first 50 terms. Now, in theory, this is going to work. However, let's go back and read the whole question again and double check that what we're doing is right. So when we read the question again, here are the first 5 terms of an arithmetic sequence, check. Here it is, A is 8, brilliant. Work out the sum of all the terms from 50th to 100, inclusive. Okay, so this is the word that's really important. Inclusive means we want to include the 50th term. So actually, we need to take away from the 49th term. Okay, because we want to include the 50th. So actually this becomes S of 49. Do we all understand? It's because of this term, inclusive. Right? So this is, if we didn't read the whole question and then go and do it, we did it the other way around, we took pieces of the question, we should always then go back and read the question again. Either way, you read the question twice, guys. Okay? So, S100 is going to be 100 over 2 lots of A, which we know is 8, plus N, which is 100 minus 1 times D is lots of 7. We're going to do this take away 49 over 2 lots of 8, plus 49 minus 1 lots of 7. If I wanted to, I can literally put that whole thing in my calculator. Okay? I would suggest, though, doing at least one part at a time. So if I do the first part, so we know that S100 is 35,450, and we know that S of 49 is 8,624. So we're going to take them away from each other, and our total is going to be 26,826. Okay, as you can imagine, a lot of people would have got this wrong because they would have used S50. Question 4. The sum of the first n terms of an arithmetic sequence S is 292. Okay, right. So as I said, I'm going to write as I go. So this means the sum of the first n terms, so Sn equals 292. That is what the first sentence has told me. It's told me arithmetic sequence as well, so what am I writing down in the corner or making sure I have available?
The formulas.
I'm writing down the formulas or making sure I have them available. So now that I've written them, it just helps me concentrate and see. It says the second term of S is 8.5. What does that mean?
Again?
The second term of S is 8.5. So the second term of our series is 8.5. So that means U2 equals 8.5, because that's the second term, right? The fifth term of S is 13. So what does that mean?
U5 equals 13.
U5 equals 13. It says find the value of n. So what do we need to find? N. Okay, perfect. So I'm going to read the information and double check that what I've done is right. So we're ready. The sum of the first n terms is 292. So the sum formula of the first n terms is 292. Are we happy with this? The second term, so if we're just talking about a term and a position, a specific term, is the UN formula, yeah? So the second term, so that means U2, is 8.5. The fifth term, so U5, is 13. Okay? Perfect. So technically, I'm now going to see what I can do with these formulas. We want to find n. So technically, what does Sn equal? 292, but what else does Sn equal? It equals the equation. So instead of writing Sn, what am I going to write? The equation. So instead of n, I know it's n over 2, lots of 2a plus n minus 1 lots of d equals 292. Okay. Does this help me? Not right now, kind of. Okay, so let's keep going. We're just going to leave that as it is, yeah? Okay, U2. Can I rewrite U2 as something else?
Yeah.
What?
8.5 equals...
8? No, not 8.5 equals. A plus n. What's my n? 2 minus 1 lots of d equals 8.5. Okay, can I do anything with this quickly? I can. A plus, what's 2 minus 1?
So A plus D equals...
A plus D equals 8.5. Okay, that's pretty cool, isn't it? Right. It is going to be. U5 equals 13. Can I manipulate this? Yes. So this means A plus 5 minus 1D equals 13. So A plus 4D equals 13. Okay, guys, so what happens now is I have 3 equations. I have this one, this one, this one. What do you think is the best thing to do?
Simultaneous equations for you.
Yes, I'm going to use these 2 first as simultaneous equations to find my A and D.
Then you plot them in the second.
And then I'm going to put them in this one and rearrange to find N. Let's do that then. So step 1, let's solve these simultaneous equations. So can you see how we break it down?
Yeah.
It's fantastic, isn't it? So A plus D equals 8.5. I'm going to rearrange this to get A equals 8.5 minus D, because I'm going to use the substitution method, right? I'm going to substitute it into this equation here. So instead of writing A, what am I going to write? 8.5 minus D plus 4D equals 13. Okay, so 8.5 plus 3D equals 13. 3D equals 4.5. What does D equal? 1.5. Is that right? What's 13 minus 8.5? It's 4.5. Perfect. Now that I know what D is, how can I work out A? Yeah, so A plus 1.5 equals 8.5. So what does A equal? 7. Okay. Do I now know what my A and D equals?
Yes.
Yeah, so A is 7. So I can substitute 7 here. And D is 1.5. So I can substitute that in here. So let's go back to this equation. Okay. So, n over 2 lots of A, which is 7, plus n minus 1 lots of d, which is 1.5, equals 292. Okay, now guys, I'm going to do brackets first, and I'm going to do this slowly. More mistakes happen here with people not expanding this right. So I'm going to start with a bracket first. So n over 2 bracket 14 plus, remember this is 1.5n minus 1.5. Yeah? Equals 292. So we're just going to carry on with inside the bracket for a second. What's 14 minus 1.5? 12.5, yeah. So 12.5 plus 1.5 n. What does this equal? 292. Now we can do one of two things now. You can either multiply everything by 2 to get rid of this fraction, or we just expand this. Should we just expand this and see what happens? Yeah, let's do it. So n multiplied, n over 2 multiplied by 12.5 is going to be 6.25 n. Are we happy with that? N over 2 multiplied by 1.5n is 0.75 n squared equals 292. What does everyone realise we now have? It's not a hidden quadratic, it is just a quadratic. So let's write it in quadratic form. I've accidentally put 7, silly. Right, so we're going to have 0.75 n squared plus 6.25 n minus 292 equals 0. Now, if I really wanted to, I could multiply everything through by 4 to get rid, or I could just put this in my calculator and use the quadratic formula to help us. Okay? If I multiply everything by 4, it'll be easy for us. Did anyone put this in the quadratic formula? Yes, what did you get? So if we put it into the calculator or quadratic formula, we're going to get two values of n. So we're going to get n equals
16 and minus 24.3.
16 and minus 24.33, etc. Now, why would we reject the negative?
Because you can't have like n, like you can't have a negative sequence.
Yeah, you can have a negative sequence, however you can't have a negative number in terms of, you can't say find the sum of the first minus 10 terms. You either have 0 terms in a sequence or you have a positive number of terms in a sequence, because it's like length, right? So that means n equals 16 is the answer. Perfect. So there we go. So you can see how we've used loads of different methods to get to this stage, yeah? All of this for 5 marks. However, the more confident you get, the quicker you're going to be, right? So the sum of the first 48 terms of an arithmetic series. So the sum of the first 48 terms is 4 times the sum of the first 36 terms of the same series. Okay, so they've told us this fact. So this is actually equals. Find the sum of the first 30 terms. Okay, so let's read the question again and double check exactly this is what we want. So it says the sum of the first 48 terms of an arithmetic series is 4 times the sum of the first 36 terms of the same series. Find the sum of the first 30 terms. Perfect. So we've got everything written down that we need. So we need to write the formulas. So we know that Sn equals n over 2 lots of 2a plus n minus 1 lots of d. And we know that un equals a plus n minus 1d. So we're going to fill in everything we know. So S48 is 4 lots of S36. So what is S48? This is 48 divided by 2 lots of 2a plus 48 minus 1 multiplied by d. This is equal to 4 lots of S36, which is 36, divided by 2 lots of 2a plus 36 minus 1 lots of d. Okay, so this is written all out. So what we're going to do is let's expand and simplify both sides. So I'm going to get 24 lots of 2a plus 48 minus 1 is 47d. Okay, so I'm now going to have 48a, 24 times 47 is plus 1128d. So this equals 4 times 36 over 2 is 4 times 18, which is 72 lots of 2a plus 35d. If I now sort this out, 72 times a is 144a. 35 times 72 is plus 2520d. Okay, so what we have now is, if you look at this, technically, we have two unknowns still. We've got a's and d's. So we could put a's on one side, d's on the other. Okay, so we know now that 40, so if I minus 144a from both sides. Okay, so 48 minus 144 is minus 96a, and then if I obviously minus 1128 from both sides, d, so 2520 minus 1128 equals 1392d, and if I divide that by 96, I'm going to get a equals negative 29 over 2d. So, however, at the minute, that doesn't really help me because I still have unknowns. So now what we're going to do is we're going to substitute this into our S30. So we know that S30 equals n, which is 30 over 2, lots of 2a, which our a is minus 29 over 2d, plus 30 minus 1 lots of d. Okay, so at the minute we don't have any more. So this becomes 15 lots of minus 29d plus 29d, which is 15 times 0. Okay, so that means the sum of the first 30 terms is in fact 0. I know what you're probably thinking. God, this doesn't seem right. However, we haven't done anything wrong. We've checked all of our working. There's physically no other way to find out anything else. This is completely correct. So the answer is 0. Okay. Now, as you can see, when that question was given, there was actually a lot of students who had assumed they'd made mistakes in the paper. However, this is the correct answer. So those of you who have done this and now realise that it's 0, well done for being confident and sticking to what you know is right. So, question 7. An arithmetic series has a first term a and a common difference d, which we already know, so it's great that they're pointing out the obvious for us. The sum of the first two n terms, so s of 2n, is 4 times the sum of the first n terms of the series. Find an expression for a in terms of d. So now we've written all this, we know our formulas. So because we want an expression for a in terms of d, we need to now sort this out. So what is the sum of 2n? We know, so it's very similar to the question we've just done. We're going to have 2n over 2, lots of 2a, plus n, which is 2n, minus 1, lots of d. Okay, and this equals 4 lots of n over 2, lots of 2a, plus n minus 1 lots of d. So, what I now get inside here is n lots of 2a plus 2nd minus d, which equals 2n, lots of, 2a plus nd minus d. Okay, so I'm now going to have 2a n squared. No, I'm going to stop right there. They both contain an n, which I'm now going to delete. Okay, not delete, divide both sides by. So 2a plus 2nd minus d equals 4a plus 4nd minus 2d. Okay, let's put it all onto one side and make it equal to 0. So if I minus 2a from both sides, so I have 2a. Okay, so I minus 2nd from both sides, plus 2nd. If I add d to both sides, it's going to be plus d. However, I've just spotted a mistake, and I'm sure you have too. 2n times n d is not 4. I think I got carried away with the 2 times 2. So actually, this becomes 0, which makes sense because I was a bit confused why there was an n in it. So that means, oh, sorry, that's not a plus either. That's a negative. So that means that d equals 2a. So a equals d divided by 2. And there we have it. Nice and easy, all done. So this is all the prior knowledge you need for A-level mathematics. Good luck, and don't forget to like and subscribe.